between the car and propeller, of course, we need to consider for the management. And in terms of engine, it's already included, but not so big issue when you didn't change speed. But in case of you change speed rapidly, you need to consider the machinery interaction. But in our case, as I showed you, we try to keep the constant revolution as possible. Without changing propeller revolution, we try to change speed. So in that case, we can avoid this problem. And second problem is the wave. And I mentioned something about wave. In case of wave, in maneuvering, it's not so important. Because if it is regular or irregular, but from the one direction, the problem may happen like capsizing. In case of capsizing, we need another approach. These are different from manual. Sorry, short answer, but I think we
do two-side wave generator producing wave right in the ocean, and you do the test.
Yes, another, I skipped the scheme, but we have several facilities to indicate the waves in some concentrating wave or some other waves. But in that case, this kind of thing, in this case, we need to develop some, the big facility. It's a kind of, it was called the snake motion wave maker, but now we are trying to make arbitrary wave maker. It can, make even to the data. So this kind of thing we may combine with conducting model test, but not in maneuvering reality. Thank you very much for your question.
Thank you. This is on this paper set. I have a bit of thing to ask and to know on this maneuverability. It is very strange to me that this wave had very little impact on this maneuverability today. And the maneuverability is also this force keeping, and therefore it is maneuverability, the rudder and all. It is not only the maneuverability in a harbor and all, and to negotiate other shapes. It is also to maintain course stability, and therefore to reduce the fuel consumption and traveling time and things like that. So maneuverability has a tremendous impact. Should be also undertaking the waves in the maneuverability analysis. I'm sure this has all been taken into this developing of these models. However, one little thing I wish to know about the paper number 3 and the study, which involves a lot of computing and all. Was it so possible when this computer was not there that strong in 1970s or 1980s to carry out this model that has been developed now by these experts?
Yes. Okay.
So there was one thing with Dr. Badi, and he is moving out. Okay, please go to the washroom. No, please come back. He is my good friend, so just I made a joke. So the next question is with the Turkish. Is it Professor Kalis? Which one will be the right pronunciation? Anyway, so the Turkish professor. So it was a very interesting subject, because I was also working some time on this. He has put some questions and has not given all the answers. That's a very good thing of the paper. Because nowadays, with the engineers, actually a great demand is coming from all the avenues. Like, some people are saying why they don't learn some more economics, because it's not sufficient to become an engineer only. And then others are saying they should be very good in communication, because they are so weak in communication, and it's not sufficient that you just be an engineer, you cannot communicate. So some people are saying, they will be saying that no, they should be knowing some psychology, because they have to run the workers and laborers, and they have to work with the people. So there should be industrial psychology a bit more. So now I am thinking one thing, that what is the actual exit? Because the courses are limited within 4 years. So is it the answer that we should make it more? Is it the answer that we should squeeze the core courses, like when you was showing that in physics and math or some in science subjects they are excelling and in others they are lagging? So what should be the real answer of it? Because how you are thinking of solving this problem? Because even from some avenue they are saying that they should be more healthy and they should take some course on exercise and all these things even, but engineers are so weak personality. So all these things are coming, and now how to solve this problem? Just what is your idea on that? Thank you.
Yeah, thank you for your question. I would like to answer your question first about student-centered education. Student-centered education is the old-fashioned way of doing things. You have the tutorial, or even if you have lectures, students were allowed or expected to go to the professor during these open hours that the professor set for students, or office hours. Now, it's expensive. It's very expensive. But I think it's the best method, because the motivation of the student is highest. You can do that as either problem-based teaching or project-based teaching. You can do that. And definitely we do that at the graduate level. That's what thesis are about there, student-centered teaching. We found that if you limit the number of student-based teaching, say, to 30%, 25%, that's pretty good. I think the students benefit a lot from that. But you also need to have the supporting infrastructures. You have to have libraries available. You have to have the computers available, or contact. I hope that I answered your question. The solution to engineering problem is unfortunately not an easy one. The main reason is, even if you decide to change your curriculum here today and you implement it, it will take at least 4 years for the student to graduate. And then he needs about 3 years of industrial training. So your response time will be about 7 years. And so that's the dynamics of education is incredibly complex. During that time, something else will happen. Another software will be there for it. So my basic idea that I really believe in as an educator is you have to give the proper information to the student so he can use them to renew himself in the dynamics of the world. If you cut him short, then he will not be able to compete. Teaching software is not the answer. Teaching software is really not the answer. But teaching the content of the software, like it was for maneuvering, for example, what's inside the software is the answer. And you should have the idea that technology it will change. In the same paper in maneuvering, we have seen that the first simulator was based on an analog computer. And then right now, of course, everything works on digital. So the most important thing I find is, first, universities must get involved in talking to the industry, communicating and measuring the deficiencies they observe. And it's like a control theory. You have to have a sensor to know where you are. If you want to go from A to B, you have to know where you are. So that path is important. Finding the deficiencies is important, and then thinking about how we can overcome those deficiencies or reduce the gap is important. And then I'd like to report that in Europe, there's a big tendency to increase the 4-year program for engineering to a 5-year program. It's a disputed target, but some of the universities are already in that, because in France, for example, the students take 2 years of general physics, chemistry, and math, then 3 years of engineering, and similarly in various places, I think that's the trend. In Italy, the students take 13 years of high school and plus 4 years of engineering. So it's not going to happen tomorrow, but I think the trend is to increase the 4-year program to equivalent 5-year program. And that's the issue.
When we had question, as the seer say, it is now necessary to know the software and to apply it. We have also seen today that the machineries are like computer, camera and all changing our life. Computer is also changing our life. Computer is changing human being also or not, that is a question. If we see the simulation, we are now learning many things from the simulator. But before that, probably it is the human brain who used that sophisticated computer and to have a sort of simulation in his brain